Okay, and here we are at the end of chapter 1. We're going to finish this chapter off with a discussion about absolute value, both in equations and inequalities. Up at the top of the worksheet, they are simply wanting us to decide whether the number that they've given us over there to the right of the semicolon is a solution of the equation they've given us. So in order to do that, you're going to evaluate the equation at x of 2. All right, and I'm getting that 2 from this number right here. And remember, parentheses are, absolute value signs work just like parentheses. You do what's inside of them first with order of operation. And when we work all that out, we see that we get a true statement. 7 does equal 7. So because the statement is true that we end up with, then we can say yes, the number x of 2 is a solution of this equation. On number 5, we'll do the exact same thing. We're going to evaluate at x of negative 9. And I'm going to follow order of operations again. These are work just like parentheses, like I said in number 1. Oh. And we end up with a 0 inside of our absolute value symbols. Absolute value of 0 is 0. So we end up now with a false statement. 0 does not equal 0. So then we can say no, negative 9 is not a solution. Okay, so again, just remember that solution and not a solution mean that when we graph this function, if it is a solution, like on number 1, if you graph that absolute value function, 2 will be on the graph. If you graph number 5, negative 9 will not be one of the points on the graph. Now in 8, they actually ask you to solve the equation. So they want you to come up with the solutions, the roots to this equation. Okay? Up above, they just gave you a number and said, is it a solution? Here, we're actually going to find out what the x's are. Oh, and we're not going to do that first. Remember, in order to do this, we have to acknowledge what the absolute value symbols mean, which basically they mean, in a nutshell, that 2x plus 6 can be set equal to 12, or it can be set equal to the opposite of 12. So remember, absolute value symbols are all about how far to the right or to the left a certain value is from the number in question. Okay, so we can always go to the right and we can go to the left as well, and that's what that negative sign shows there. So you have to, when you drop the absolute value signs, you have to indicate that, acknowledge that by rewriting two equations. All right, so then you're just gonna solve it. Oh, that's not 8. That is 6. And you'll just solve it the way you typically would. So x is 3 here, and x is negative 9 on this side. So if we were to graph this equation, the solutions are 3 and negative 9. That's where the graph will cross the x-axis. Okay, so we're going to acknowledge that 2/3 x plus 2 could be to the left or right of a given number, but in this case, the number we're talking about is 0, and we don't have a negative 0. So because of that, we're only going to end up with one rewritten statement, and we're going to only end up with one solution. And you know that that means that when you graph, if you were to graph this, it would only cross the x-axis in one place. Okay, and that one place would actually end up being the vertex of this graph, because it's going to be sitting on that number. Let's go to 1. You end up with a negative 3. So if we were to graph it, the vertex of this this graph would be sitting at x of negative 3. There's only one solution, so it's only hitting that x-axis one time. All right, so drop the absolute value signs, acknowledge the fact that means that this expression can be 3 to the right or 3 to the left. And then solve as you normally would. All right, multiply by your reciprocal. And you're going to end up with x equals -10 and x equals 20. Okay, so again, two solutions. That's where it's going to cross that x-axis. Okay, so down here on the back, they ask you now to solve the inequality. So now we've just switched from equations to inequalities. There's one little extra step to do this, but essentially the steps are the same. We're going to drop the absolute value signs by acknowledging what they mean. And so I'm going to rewrite it the way I see it first. I didn't change anything except to drop the absolute value signs. And then next, I'm going to turn the inequality around, turn it to less than, and change the sign on the 5. So you have to do both of those things in order to acknowledge what the absolute value, the definition of absolute value means in an inequality. And then from there, you're going to solve as normal. You end up with x is greater than 4. And x is less than or equal to -1. Okay, that 2 was positive. Remember, if we had been dividing through by a -2, then we would have had to change the inequality signs to go the other direction. We didn't have to do that on this one because we didn't multiply through by something negative. Okay, so I'm going to acknowledge the absolute value signs by rewriting and writing two different statements. The first one looks identical to what was already there, except for no absolute value signs. And now I'm going to acknowledge the fact that it could also be greater than or equal to the opposite of 9. Oh, not 16. All right, so x is less than 4, or x is greater than or equal to -1/2. Again, that 4 was positive, so I don't have to, I didn't divide by a negative number, so I don't have to change those inequality signs. All right, and then one more time. Dropping the absolute value signs, rewriting the inequality, and acknowledging the fact that it could also be greater than or equal to the opposite of 6. All right, now look, I'm multiplying now by the opposite of 2. So because of that, I have to change the less than sign to a greater than or equal to sign. All right, and then I can expect that on this side as well. All right, multiplying through by -2 means that I turn that back to a less than or equal to sign. And there's your final answer for that one. Okay, in 25 and 26, we're going to apply this concept, and these are challenging. We did touch on this a little bit in Algebra 1. We're going to go into more detail about it in Algebra 2, and if you don't understand it right away, there's a lot of terminology here, and it's just kind of a different way of thinking about things. So it's okay. We'll just keep talking about it, and eventually you're going to understand it, and it'll help you really understand the whole idea of absolute value in general a little bit better. So the first one is talking about a golf outing that you're going on with a friend. You guys have two choices. You can either go to your favorite course, which is 14 miles north of your house, or you can go to your friend's favorite course, which is 14 miles south of your house. So everything is in terms of your house. The furthest you're ever going to be away from your house is 14 miles. It's just in opposite directions. So if we I'm going to call the positive end of the number line north, and the negative side I'm going to call south. So really, negative in this case really means south. But we're talking about your house, and so you know that if you were to find the average between those two numbers, You don't even have to do the math to do that. You just know automatically that 0 on the number line would be your house. Okay, so here sits your house. All right, and your friend, and you are going to either travel north or travel south. At any point in time, you're going to be on your journey, you're going to be a certain distance from your house, but you're never going to be more than 14 miles. That's what they want you to write in an absolute value inequality about. It says write an absolute value inequality that represents all the distances you may be from your house. So we know we have to deal with a variable. All these inequalities have a variable in them. I'm sorry, all these absolute values have an inequality, have an x in them. And in this case, x is going to represent, according to that last sentence, it's going to represent you and your friend's distance from your house. So we know that that x is going to be sitting inside the absolute value symbols. Okay, so we know we can start there. And we also know that the furthest you could ever be from your house is 14 miles. Okay, if you go out and go to the north, the max you can be is 14 miles. If you go out and go to the south, the max is 14 miles. So that is going to be the number that sits over here. So what we know so far is that x, your distance from your house, can be no more than 14 units. In this case, it was miles from your house, which sits at 0 on the number line. Okay, so 0 on the number line represents your house. So the 14 out here is called the tolerance. Right, this is the max you can be either direction from the mean of the extremes, which is what we call this right here. All right, the extremes being the extreme north distance, which is 14, and the extreme south distance, which is that negative 14. Okay, we don't actually need to have that 0 in there because it's a 0. We can take that out and just leave it as x. Absolute value of x is less than or equal to 14. So that's your actual answer. If you solve for it like you did up in the other problems, like if you said, oh, what are the exact values of x? You would get x is less than or equal to 14, and then you would have to acknowledge that absolute value sign by changing the inequality and taking the opposite of that of that 14. And you can see up there on the graph, I mean, what we're talking about is all the possibilities of x, all the places that you could be on this number line if this were your journey, and that's this blue line right here. So these two do satisfy that. X is greater than or equal to negative 14 and less than or equal to positive 14. Number 26 is a little harder to visualize because it's not distance. We're talking about length, and in this case, length of adult garter snakes. They have told you in the problem that they can range in length from 46 to 130 centimeters. So they can be as short as 46 and as long as 130 centimeters. Those are the extremes. Okay, so you're going to put the lower extreme here if I were to just show you a visual, and then the upper extreme would be on the other side. Okay, and then from there we know that we have a middle. We have the mean, and so up in the problem above, it was easy to see it and know that it was 0. But in this one, that's harder to do. So we're going to actually just find the average. We're going to find the mean. You take the top number, and subtract the bottom number from it and divide by 2. That's your average formula, and you're going to get 88. Okay, so this number right here is called the mean. That's another word for average, if you remember, of the extremes. So that's a really fancy way of saying we found the average of the two numbers, the top and the bottom range numbers. So that means right in the middle, sitting in between these two, is 88. Now, at, at this point, we need to find that number that is the tolerance. How far from this median, from this mean, can do the extremes sit? Okay, so I'm going to use the biggest number, the 130, subtract that mean from it, and that will give me my tolerance, which is, in this case, 42. So what that means then is that if I show you visually here on the number line, from 88, okay, the length of a snake can be to the right of it 42 inches to take it to 130, or it can be to the left of 88 down to negative 42 to 46. So how do we write this then? So we actually need to, everything I've shown you so far is just leading up to us actually writing this absolute value inequality. Now we need to know and just define what x stands for. And in this case, x, based on that last sentence there, it says write the absolute value inequality that represents the range of lengths of adult garter snakes. So this x is representing all lengths of these snakes. Okay, and so what we know from the math we just did, first of all, we know that we need absolute value signs. We know that x is going to be there in the front of that absolute value symbol. And what we know is that x cannot deviate more than 42 centimeters from the median or the mean of those extremes, which is 88. And we know that it cannot be more than that. So it has to be less than or equal to that tolerance of 42, or another word for it is to say deviate. So the formula for this is the actual length minus the mean of the extremes, and that is less than or equal to the tolerance. So those are all the vocabulary words being thrown in there. I know some of you that will be really helpful to some of you to have the actual formula. Some of you will just kind of be able to understand how it's all fitting together and won't necessarily need that formula. But if you need it and it is helpful to you, then make sure you understand that and have that in your head. This is the answer in the box, but if we were just to take it just a step further for a minute and go ahead and solve for x, then you would drop the absolute value signs, acknowledging what they mean, which is that right there, those two inequalities. If I solve for this one, I'll get x is less than or equal to 130. I solve for this one, I get x is greater than or equal to 46. So if you look back up here at the number line, let me shrink this down. You look back up at the number line and you can see that is what's represented there. That's what is represented on, I'm going to make it green, this green line right there. X being greater than 46, greater than or equal to, and less than or equal to 130.